Welcome to The Explainer. Today, we're diving into the architecture of knowledge itself. We're talking about something that is the foundation for every single study you've ever read about, research design. Have you ever wondered about that? You read one study and it just feels solid. It clicks. But then you see another one and it feels, well, kind of flimsy. So what's the real difference? Well, you might be surprised to hear it's not always about the data itself. That's right. The real secret, the magic, is in the plan that's made before anyone even thinks about collecting data. It's just like building a house. If you want a structure that's going to last, you absolutely need a solid blueprint. So let's unpack what this research blueprint actually is. You see, once a researcher figures out the problem they want to solve, the very next step, the most critical step, is designing how they're going to find the answer. Okay, so what is research design officially? Think of it as the master plan. It's the essential bridge that connects the question you start with to the conclusions you end up with. Without a good one, you're pretty much just wandering around in the dark hoping to stumble on an answer. Now, here's something that trips a lot of people up. It's so important to not mix up the blueprint with the tools. The research design is the big picture, the what and the why of your study. Research methods, on the other hand, are the specific tools you use, the how. Think surveys, interviews, lab equipment. You always figure out the blueprint first, and then you go pick your tools. And listen, not all blueprints are created equal, not by a long shot. A really good research design has a few non-negotiables, kind of like how a building needs structural integrity so it doesn't fall over. Let's get into the most important ones. First up, and this is a big one, clarity. Your goals, what you're measuring, the scope of your study, all of it has to be crystal clear from the get-go. Why? Because a vague design always, and I mean always, leads to confusing, muddled data. And you can really see the difference here. A vague plan, like just saying you want to study student performance, what does that even mean? It's way too broad, but a good design nails it down. It specifies exactly what's being measured, how it's being measured, and who's being studied. It gives you a clear road from your question to your answer. Okay, next up is validity, and this one is absolutely crucial. Validity is all about accuracy and truthfulness. Plain and simple, is your study actually measuring what you claim it's measuring? Because if it's not, the whole thing is built on a foundation of sand. Here's a perfect example. Say you want to measure learning quality. If you just count the number of pages a student read, well, that has pretty low validity, right? Someone could stare at a book for hours and learn nothing. A much more valid approach would be using something like standardized test scores to see what they actually retained. And our third hallmark is reliability. This is all about consistency. Think of it this way. If you or anybody else ran the exact same study all over again, would you get pretty similar results? A reliable design makes sure your findings aren't just some random one-time fluke. Just imagine taking a survey about your stress levels and it gives you wildly different scores every 5 minutes, even though nothing in your life has changed. That's a tool with low reliability. A good, reliable questionnaire, however, will give you consistent, repeatable results. And that's how we build real trust in scientific findings. Okay, so once you've got those core principles, clarity, validity, and reliability locked in, you have to choose what kind of structure you're actually going to build. And the choice for your blueprint usually boils down to two main types, causal and experimental. So first, you've got causal design. This is what you use when you want to see if X causes Y. Does drinking more coffee lead to better focus? This kind of design often looks at the world as it is, using statistics to find relationships in data that already exists. But if you need to prove that X causes Y, beyond a shadow of a doubt, well then you need an experimental design. This is really the gold standard. In this case, the researcher isn't just a passive observer. No, they are actively changing something, controlling everything else they can, and then comparing the results. And this table really lays out the trade-offs perfectly. A causal design is awesome for exploring relationships out in the messy real world, especially when you can't or shouldn't run an experiment. But an experimental design, with all its control and manipulation, gives you that powerful proof of cause and effect, even if it is usually a lot more expensive and complicated to pull off. A bad blueprint can completely doom a project before it even starts. So now let's talk about how to avoid some of the most common design disasters, those critical, fatal flaws that can make a whole research project come crashing down. And you really need to let this sink in. The most serious, unfixable errors in research don't happen when you're analyzing the numbers. Nope. They happen right at the very beginning, in the design stage. These are the cracks in the foundation. So here are a few of the biggest culprits. You've got sampling errors, where your study group isn't a good reflection of the bigger population. Then there's selection bias, where the way you picked your participants pretty much guarantees a skewed result. You can also have measurement errors. Your tools are just plain wrong. And finally, confounding errors, where some hidden factor is what's really causing the effect, not what you think it is. Any one of these can be a total disaster. Seriously, if you take just one thing away today, let it be this. You could have the most massive, impressive data set in the entire world, but if your research design was flawed from the start, that data is basically worthless. The blueprint is everything. So the next time you see a headline about some amazing new study, don't just get wowed by the big numbers. Take a second and ask yourself, what was the plan here? What was the blueprint? Because learning to ask for the blueprint is how you really begin to understand whether the science is solid.